Alright, hey guys, so if you're here, it's probably because you saw the video that Carmen and Terry did where they talked about things like why we need to pump down the beer keg fusion chamber, but they also talked about the radiation shield. So they went over kind of the basics on it, so here we're going to get a little bit deeper into the science end of things. We're going to talk about why we're using the radiation shield and how it all works. So the big thing that we're trying to measure from these fusion reactions is they create gamma radiation. So if you don't know what gamma radiation, that's okay. So gamma is basically like, it's really intense light. And it's light like this light right here, but super high energy, very, very intense stuff. And so if we measure these gamma rays that come off of these fusion reactions, then we know what reactions are occurring. And so one of the things that we want to do is we have to eliminate what's called background radiation. So we're constantly being bombarded by cosmic radiation. That means that that's like gamma rays and high energy particles and all that stuff that are coming from the sun that are bombarding us all the time. We also need to, there's also radiation that's coming from the Earth itself, from uranium and thorium and other elements such as that. We also have radiation coming from people. Potassium-40, carbon-14. These are radioactive isotopes that's in my body, it's in your body, it's like any given second we have something like 4,000 potassium-40 decays in our body every single second. So, the world's a pretty radioactive place, but these are naturally occurring radiation sources. But that's a problem for fusion. Nuclear fusion reactions are much cleaner than fission reactions. And so the issue is that when we go to take measurements of these things, we get a lot of interference in the background. So we need to do whatever we can to eliminate that cosmic ray background radiation, the radiation from the Earth and the thorium and uranium and all the other stuff, and the radiation from us. So we have to use radiation shields, not to protect us from the nuclear fusion reactions, but to actually protect our experiment, our nuclear fusion reactions from us, so we can get a good, clean measurement. And one of the ways we do that is, Carmen showed, is that we use that lead shield. Now, actually before we get into that, so let's talk about how the lead shield works. So let's say we have a background radiation. We have a gamma ray. So gamma, it's a light wave, so it's a wave, it's coming in. If that hits an electron, which is part of an atom, it's going to bounce into that electron, and it's going to impart some energy into that electron. So that electron is also now going to have some velocity. It's now shot away from here. Well, conservation of energy tells us that this gamma ray, whatever energy it gave up to that electron, is now lost from that gamma ray. So now it has less energy. And then that'll hit another electron. And that does another what's called Compton scattering, just like this event right here. And that electron will have some kinetic energy to it, and then it'll have even less energy, until eventually the gamma has no energy left inside of it. So if we use a material that has a high electron density, it will make for a good radiation shield. And one material that's easy to melt, easy to work with, that has a high density, which also means it has a high electron density, is lead. So you guys probably remember this from Carmen and Terry's video. If you guys hadn't seen the video, I'll put a link to it somewhere up here. Go check it out. Great video. So this is the shield that Carmen built. If you notice, this hand's barehanded because I broke all my gloves. This is my last one. So, if you handle lead a whole bunch, you want to kind of limit your exposure to it because it is toxic. It's a heavy metal. We'll talk more about that inside another video. I'll put a link to that somewhere up here. Go check it out if you want. You can learn why lead is so bad. Okay, so this radiation shield, if you notice, it has a big hole on one end and then a small hole on the other end. That's actually by design, and here's the reason why. So we have our fusion reactions. They're emitting gamma rays in all these different directions. Then we have our radiation shield. And then on the other side of the radiation shield, we have our detector. So this is the detector right here. And what this detector does is it picks up the gamma radiation so we can measure the fusion reactions that are occurring in our experiments. Well, we want to block the background gamma radiation. We want to have this effect come up, this Compton scattering, so that way we can go ahead and we can eliminate these gammas so we're not getting false measurements. We only want to measure the gamma radiation that's coming off of our nuclear fusion experiments, not from the gamma radiation that's coming from our bodies, from the potassium-40 decay or whatever else. So this cone shape goes like this. And so what will happen is these gamma rays can still come off of this reaction, and they can go into our detector, and we can pick up these gammas from our nuclear fusion experiment. But the background gammas are now coming up, and they hit this lead. And when they hit this lead, they're hitting the electrons, and they're losing energy, putting energy into the electrons, hitting other electrons, until eventually there's very little gamma making it through. And so that reduces the amount of background radiation that our detector picks up, and we're primarily just getting the reactions from our nuclear fusion. And that's basically it. And there's a bit more to it than that, but that really kind of covers like the big gist of what we're trying to do with this radiation shield and why it's so important. We actually have some ideas on how we can improve this for down the road. So we'll talk about that. We'll show you guys some of the other radiation shields we have as we start putting them into development. Because frankly, we're building up this experiment as we go. If you have any good ideas, suggestions, let us know. Leave a comment in the comment section below. And of course, don't forget to like and subscribe.
Like, subscribe. Like, subscribe, stay tuned for more.
Okay, we're recording?
Yeah.
All right.